Hi guys, it's Rob here with another Unity tutorial, and today we're going to be going over game production in Unity. The material that I'm teaching you is directly in alignment with NJIT's IT 286 Foundation of Game Production course. Specifically, this is a midterm review, so for those of you in that course, this will serve as a midterm review. For those of you wanting to learn about game production in Unity, you're in luck because none of this is course specific. This can all be applied directly to Unity, and whether it's technically or just conceptually. So what is a game? A game is a series of interesting choices. Unity is a game engine, and then you have content creators, right, like Maya, 3ds Max. Those are where you make the content in Photoshop. You make the content, bring it into Unity, where you use scripts to bring that content to life. The game view is what your active cameras actually see. The inspector tells you information about whatever you have selected in the hierarchy. A game object. All objects in Unity that are Unity objects, meaning everything in the hierarchy, are game objects. Components are what a game object is made up of. And one key point is that the transform component is always on each game object and can never be deleted, right? And the transform component contains rotation, scale, and position information. And there's terminology we're going to enter: local and global world space. Right? Local space is an object's position relative to its parent. Global is an object's position relative to the 0, 0 or origin of the world. Moving a parent will move a child. Moving a child will not move a parent. With parent rotations, we use pivot, not center. Right? Within a scene, you need an object, a camera, and a light source. Components define what an object is and what it does. Components can also be enabled or disabled, either in the inspector or through code. GameObject.find hooks up objects in a scene to a new game object during a scene change so that you can still find things after the scene change. Tags are useful for identifying objects and figuring out what class they belong to. Layers are more important than tags. They matter for physics and cameras. Scale factor, it's important to identify units in Unity. Compression and stuff is done at build time, not on the object itself. So what are meshes made up of? Vertices, which are points, triangles, which is the order of points to determine normals, and UVs, XY positions that determines like a texture's layout on the object. And this is actually one of the possible exam questions from the IT 286 class. When I took this class on the midterm, or actually this question I believe was actually on the final for that one. But this is definitely a possible exam question, so make sure you know that, all of you in that class. Now, a diffuse shader will calculate based off of how light should affect these base colors. Materials, okay, are shaders plus textures at plus whatever other settings. Right? Does a rig get exported with the FBX, which is, the export from Maya or 3ds Max, which is an export type? Yes, but Unity defines the type. When talking about types of rigs, there are three types we can talk about. Legacy, which is using Unity's old animation system. Generic, which are non-human rigs. And humanoid, which are human rigs. Okay, and remember, a rig is like the setup. It's putting bones into your character to get ready for animation, basically. Game objects. Rigs are actually prepping the mesh for animation, would be like the sort of the formal definition there. Game objects. Components are attached to game objects. You can't remove the transform component. And when dealing with a game object, we're dealing with the local space in relation to that game object. Now, floating point precision is single precision. And the important point here is that lighting uses half the precision of a float. Now, that's not too important of a point. Just wanted to make that distinction. Graphics card. This is important right here. A graphics card calculates the cube to have 24 vertices because it creates a vertex normal separately for lighting calculations. Right? Let me say that again. The graphics card calculates a standard 3D cube to have 24 vertices because it creates each vertex normal separately for lighting calculations. Now, Unity's camera system. A camera is a method of displaying information to the game screen. Render textures are a way to produce effects, but they're expensive to the game object. Now, clear flags are methods to which the camera will clear everything drawn to it. Now there's skybox, which is obviously if you have a skybox in the scene, you want that on. Solid color, which is if you want a solid background color in your scene. Depth only will only render objects at a different depth than the previous iteration. And don't clear. And these can also apply to transitioning to another camera. Don't clear is used on a secondary camera, obviously. And depth, the lower the number, the earlier it is rendered. Now, culling mask, everything you set everything on these layers to render. And these are used for selectively rendering groups of objects using layers. So the culling mask basically defines what is rendered. Right? Now, it also defines what layers the camera can see, essentially what is rendered to the camera, or to the screen. Now, projection, you have perspective, which is things look like they are at different distances based on your perspective view. Orthographic, as you change distance from the object, it doesn't change size. Far and near clipping planes are the same. All games have a variable frame rate, as the game loop takes a variable amount of time to run. Normalized viewpoint rect, 4 values that indicate where on the screen this camera will be drawn in screen coordinate values 0 to 1. And remember, we're still talking about components on a camera, right? So this is how they tie into cameras in Unity. Now, a viewpoint rect, give it a value between 0 and 1, which gives it a place to render. Isometric is axonometric projection, and basically this just means all of the lines are of their true length. So you have perspective, orthographic, and isometric. And it's a method for visually representing 3D objects in 2D. Now, for lighting, we have a directional light. Causes all the things in the scene that are part of the culling mask to be hit by the light at that angle. It's super cheap if you're in forward rendering mode, which is the default. And also, it doesn't matter where you place this light. What only matters is the angle, because that's the angle that's going to hit all the objects in your scene. But a directional light essentially hits all objects regardless of its position. Can change the color of the light, the intensity, etc. You can add a flare to it. You can increase the softness and resolution of a shadow to get some really nice aesthetics. So I suggest that, if you are trying to go into some lighting effects, that you would go into Unity and you actually play with that setting. The cost of shadows is really high. After a raycast, the shadow is drawn from the perspective of the camera. Every room, no matter how dark, should have ambient light. And a bump map is technically equal to a normal map. Now, there's a distinction, I guess, in Unity, or sort of talking about game production from an objective standpoint. I guess these two things would sort of, from a basic standpoint, these two things would kind of be the same. But there is a sort of distinction where a bump map really technically shows the bumps or raises an object. And it's a grayscale map, whereas a normal map uses RGB values, and it technically does sort of the same thing. So, I mean, we're calling it equal here, but just know that those two things, bump map and normal map, are a bit distinct, although you'll hear them a lot equated in the industry. What component can't be deleted? Pop quiz. Well, it's transform, as we mentioned above, right? Now, physics in Unity. Well, they're controlled by colliders, which control how objects interact, and rigid body, which ties into the physics engine. Now, terrain. A terrain object will have a terrain script and a terrain object, right? Edit texture, add texture. That's how you would add a texture to your terrain. The first one you add will be the default texture, and you can use shading and blend between terrain textures, right? A terrain collider will basically allow rigid bodies to collide with this object. And you cannot have more than a single height at a point. So in other words, you can't create a cave with a terrain tool set. Now in terms of game design, we have player versus player, where luck is evenly distributed between the two players, and multiplayer situations rely on skill. A good example of this is the Counter-Strike video game, and a bad example is Mario Kart. Why is Mario Kart a bad example? Because they give players the blue shell if they're behind. They use that blue shell to knock the first place guy, back, or whoever's in front of them, and they catch up. So it's now no longer relies on skill. If you have less skill than someone else, it's not being reflected in the results of what's going on. In other words, if you have so much more skill than another person, they shouldn't have the opportunity to catch up to you based on something programmed into the game. That's the argument. Now, player versus gameplay balance. That means that there's a learning curve involved. The interface doesn't get in the way of gameplay. And it implies the interface doesn't get in the way of gameplay. And one more thing I want to mention is that any first-person shooter that uses a controller has bad player versus gameplay balance because technically you're not playing the game, you're playing the controller. So it's not testing how well you could actually, shoot the gun, so to speak. It's testing how well you could hit the buttons that control shooting the gun. Now, gameplay versus gameplay balance. Features within a game are balanced against one another, right? It gives players reasons to use items or weapons, right? It offers the player a choice about which weapons they will use. World of Warcraft is an example. For example, the Ice Mage slows things down, but the Fire Mage does more damage. So do you want the safe approach, slowing the enemy down, or do you want like the quick kills, StarCraft 2 is another example. Now we're going to do a quick recap on physics in Unity. Terrain objects. Terrain is just a height map, so we can't have caves. Rigid bodies, right? And static friction is the force that must be overcome to start moving. Dynamic friction is the force acting on the currently moving object. And I'm actually going to highlight this. Somewhat important. Now, scripting in Unity, this is a huge topic. While all components should extend from the model behavior class or classes that extend from it, we have start, update, and awake. So remember, these basically, awake is called before start. Awake and start is for initialization. Update is called every frame. Now there's fixed update and late update, which are mentioned here. Fixed update just means that it's called every physics step, which removes the problem of different frames taking longer to render. And late update is called after all the other update functions, but it's still called, I believe, every frame it is. Now awake, like I said, is much better for initialization because it occurs before start. Debug.log is a useful tool for debugging. It's like printing to the console. Now, tagging is always checking for a string. When you use tags and you work with tags, you're always checking for a string. The way that's different than layers is because layers can check a bunch of things. They're not restricted to just the string data type. Now, if other.gameObject.tag, remember that these if statements should be lowercase. I just autocorrect on Microsoft Word was capitalizing them. This is how you check if a game object's tagged with something. If other.gameObject.tag double equals sign, now open quotation mark, this is the string with the tag name in here. The reason we would use this, right, is to check if the game object we've collided with has that tag. Remember, other, right, is the collider that's being passed in, so you can't just use this as a standalone if statement. It's inside of a function that's passed in collider other. Normally that would be your on collision enter, on collision exit, on collision, on trigger enter, those ones, right? You would use this inside of. Now, if other.transform.position.y, this accesses the object's y position. Now, of course, they're enclosed in if statement, so this means, if we get this, do this. But, that obviously, this is just an example here. The monobehavior's print, where were we? Is identical to debug.log. On collision enter is upon entering the collision. On collision exit is called upon exiting the collision, and on collision stay is called while the two objects are colliding. Now, changes made in play mode are not permanent. If you run into the situation where you're in play mode, right, and people think hitting pause takes them out of play mode, no, you have to hit play again. So play mode is a situation that occurs when the play button is pressed, right? And then when you go to make changes and you haven't clicked the play button again to unpress it, the changes you're making aren't permanent. Now, if you run into this situation, don't just unclick play mode, because that'll revert all of your changes back to the way they were. Calmly, just make a prefab of all your changed objects. The prefab will save those changes, then exit play mode. So that's your one way out. Okay, but avoid that situation altogether by always double checking to make sure you're not in play mode before you make changes. Now, Unity only draws stuff to the camera that is visible, obviously. So if you turn off, let's say, the mesh renderer of a cube, it's not going to be visible to the camera. So this is a way that you could set up sort of invisible triggers and colliders and stuff like that. This is sort of the way that you could do that. Now, triggers are a method of using colliders without using physics. And another exam question that I had on one of my exams was, what's the difference between a collider and a trigger? Well, a trigger is the same as a collider, except that you check that little is trigger box on the collider, and that means that you're now no longer using physics. Physics is no longer applied with that. So it's going to check the collision without physics. So now if you have a collider on your player and a collider on the platform below him, and you check is trigger on one of them, he's going to fall through the platform. You may ask yourself why. Well, you technically turned off physics with that specific collision. Now, you would only put rigid bodies on things you want physics to act on, which means that walls should not have rigid bodies. If you declare variables as public, right, Unity declares it for you, and it makes it visible in the inspector, right, if it is a serialized type. Now, if you're in Unity, go to Edit Project Settings Input, right? Using the above would be for get axis, right? And now blank times time.delta time, so a value times time.delta time is used to account for the frame rate. In a similar way, we would use fixed update instead of update, which is called every physics step. So these are just ways to account for different things taking longer to render or longer to take place, right, within a certain frame, which changes the frame rate. Now, AI programming, we use AI behavior trees. State machines are a series of states and a method of moving between those states. And now I'm going to show you an example in Photoshop that I drew. So basically, this is an example of an AI behavior tree. You can see that we have 1 patrol, 2 attack, 3 return to patrol. That should say not control. So this should be patrol, right? And basically, here's what's happening. We've diagrammed this out. Now remember, a circle with the 1 in it, this corresponds, right, to these states. And A, B, and C are technically like conditions. Now this is really important for those of you in the IT 286 class. Why is that? This is usually the 3rd exam question. Now, on the IT 286 midterm and final, let me step back and just explain this for a minute. There are 3 questions. And we're going to get more to the structure later, but just know the 3rd question is worth the most amount of points. And it's the big question. And this is usually like the big question. And sometimes you would also have to, maybe write a little paragraph just explaining these states as well, or explaining the transition between these states. But the diagram here is really the key point with this labeling. Right now, depending on the question asked, could imply more. Now remember, these everything I'm drawing in red is just to show you. Everything drawn in white is what you would have to write on the test. Now basically what's happening is our guard is in the patrol state, right? Now once he spots the player, he moves to state 2, which is an attack state. He goes after the player and attacks him, right? Now, after the player is either lost to his area of vision or killed, the patrol he changes to the return to patrol state, and once the patrol area is reached, he returns to his patrol state. So there's a return to patrol, which is returning to the patrol point, and then there's patrolling at that patrol point. So these are the 3 states. These are the 3 conditions. Now, I'm going to assume that you would be able to replicate that example given different conditions. So I'm going to go back to the notes, and I'm going to continue with this. So a behavior tree is a state machine, and the entire thing becomes a decision tree. Now, a prefab is a game object stored in the library. Any changes made to a prefab in the library will be reflected to every instance of that prefab in the scene. Now, if you change one in the scene instead of in the library, go to Game Object, apply changes to Prefab if you want that change to affect all other instances of the prefab, as well as the prefab itself in your library. Now, waypoints we're going to talk about. Now, technically, we're not really going to get into waypoints here. I'm just moving into the category of AI programming and pathfinding. So this may be a bit misleading of a subheading. A star is the generic pathfinding algorithm. Okay, and if you look on the internet, you're going to find tons of information about the A star algorithm. And so this is literally the generic pathfinding algorithm. I'm actually going to highlight the word the, because this, if you say, a generic pathfinding algorithm, A star is the primary one. And there's a ton of other ones, I believe, but they all derive off of A star, or most of them derive off of A star. A star is really like the go-to one. So I guess that would sort of be, no, I don't believe that would be a question 1, because question 1 is usually Unity specific. But just know A star just in case it appears on a test, or if you're studying this, and you want to be an AI programmer, definitely learn A star. I'm not going to go in depth in A star here. Literally, what I'm going to tell you about A star is the generic pathfinding algorithm. You'd have to take it on yourself, or I'd have to make a separate tutorial on it, but as of now, this tutorial is not going to include it. C# has coroutines, which are asynchronous update functions. Coroutines cannot act on game objects that aren't active, which means if we disable a game object, our coroutine will not act on it. Now, physics.raycast can be used in a number of ways. Now, just to get into array real quick, array is made up of two vectors, a direction, and an origin. And that's all I'm going to say on raycasts and rays. So if you're interested in that, again, that's something you would have to go look up, because I'm going to move forward more with an overview, sort of the midterm and course material. Now, there are two models for memory management. Now, this is important because it may be an exam question. I forget specifically if I had this as an exam question, but in the future this actually may, and I believe it's been a question in the past, where there's two models for memory management, right? One, you could have one scene with prefabs, where that one scene handles everything in the game. You just make everything a prefab in it, everything's saved, and you specify what you want to destroy. The other way to do it is to have many scenes or many levels, right? And you switch between the scenes. Now the difference here is everything is destroyed after you change scenes. You need to specify which objects that you want to keep. Okay, don't destroy unload game object with the game object argument passed in. Is how you prevent a game object from being destroyed on a scene change. You would simply pass in what you don't want destroyed, and it would make sure that it's not destroyed. Now, there are certain problems with this. For example, I was working specifically on a game for, basically, it was a 3D platformer, and I was trying to load the level. I was trying to not destroy the player character. Now, what that did was create a bunch of different instances or clones of the player character, and it sort of, you know, it messed up the game. It gave me an error, but not like a specific error. It gave me like sort of a crash, but not a crash. It was just like continuing to instantiate them, and it was a bug, right? So what I had to do is I had to make a whole other scene that contained, I forget what it was, like the instantiation code or something, and I could never touch that scene again. That scene was called once and only once at the beginning of my program, and it loaded up another scene, and that handled it because now it wasn't making repeated clones of that game object. So if you run into that problem, you know, there's definitely online resources to help you with that. I'm not going to get into an in-depth example here. Again, I'm going to move forward with the course material. Now, you can also make everything you're carrying over a singleton. Singletons we make when we only ever want one of an object. We make it a singleton. And it's a static reference that gets instantiated when the object is instantiated. So, well, this is now a new topic. Cinematic effects in Unity can be achieved via effects under menu and then components. This is just misspelled, right, in Unity. But be careful, because these may break player immersion. So be very careful with that. Now, if you're going for the cinematic look, that's a different story. Now, particle systems have many uses. Continuing effect. If you want a continuing effect to take place in your game. If you want to animate a torch, for example, or a flame. Or make an instantaneous effect, for example, an explosion. Or make a trail behind an object, for example, a star power leaving a trail behind it. Now, for duration, now these are all components. What follows are components attached that work with the particle system or settings within a particle system. I'm not sure of the exact terminology, but duration specifies how long or what is the cycle of that particle system. Pre-warm makes it start as if you had it on, but then you can't have a start delay. And a start delay is a delay before the start, but you can't have a pre-warm. So obviously, if you want the particle system to look like it started up before you actually had it on, you're not going to put a delay before this, and you're also not going to put a pre-warm if you wanted a start delay. So you actually can't do that. That's like impossible for you to do. You're not able to do that. Unity won't allow you to do that. And if it does, you'll get an error. Now, the gradient editor, you can change the color and the alpha separately. Now, one important point to note is simulation space. Now, local means all particles move with that object. World space means all particles emitted become part of the world, which means we no longer care about the position or rotation of the emission point of our particle system. It's an important distinction to note. Now, play on awake means whether or not you want it to start playing when the awake function is called. Now, max particles is the maximum number of particles. And remember, all of these base settings can be accessed in code. So if you want to change one of these settings in code, you can do that. Now, emission is how fast the particles come out. Shape is what is the shape of the emission. And you can import the particle package to obtain particle materials, which you can apply to the particle system. Now, shaders with additive, right? The additive type, multiple layers get closer to white. Now, this is because our values are represented, all colors are represented by 0 to 1. So if we add, let's say, 0.2 and 0.2, and we get 0.4, that's closer to 1. So we're getting closer to white. Remember, 1 represents white on the color scale. Now, alpha blended means that you're not combining the colors. Alpha, remember, is transparency control. So you're no longer combining the colors. Right? Multiplied multiplies the current color by the other color. Now, since all colors are 0 to 1, remember, it gets closer to black. Because when you multiply a number less than 1 by a number less than 1, it gets closer to 0. Remember, multiplying by a number less than 1 is equivalent to dividing. Now, sort mode is a way to guarantee that particles are on top of each other. By default, the sort mode is none. Now, the specific breakdown, for those of you in IT 286, the specific midterm breakdown would be as follows. And this is also the final breakdown. And I'm also going to make another tutorial video at some point specifying final review, and again, building on more topics, just for those of you who are just interested in the material, not even taking the course. Now, question 1 is Unity specific. It's a one or a few word answer. Question 2 is game design related. It's a few sentence answer. And question 3 is like, you know, what the professor calls a reading comprehension question, or a long response question. Basically, he'd give you a little bit of sort of food for thought. Let's say, now this isn't always the case, but he'd, let's say, give you a description of a guard's behavior, and you'd make a behavior tree for him. Right, so an example of a question 1, what component can't be deleted off an object? Well, game object, well, that's a transform. The transform, right? It's one word answer. Now, what is the difference? Question 2, what is the difference between local and global world space? Well, local would be with relation to the parent, whereas global would be with relation to the 0,0 origin of the world. Right, and question 3 would be given a description of the guard's AI behavior, write his behavior tree. So these are just examples. It's very possible that you'll get one of these the exact question, but it's almost, well, since different things are going over each semester, I can say that the topics I'm discussing here, will like be a really good start, but it's also going to be specific to what's gone over in your class, obviously. Now, no coroutines, that's important because that is covered. It was covered before the midterm when I took this course. So no coroutines. And now, for those of you not in the course, this is actually important for you as well. So get key versus get button. Get key specifically names keys for using key codes, whereas get button accesses all of the input stuff specified in the input manager, where you would choose an input and specify a key or button for it. And remember, you could access the input manager by going to, where did I write it? You would go to the get access stuff. So get access. One match. Okay, here we go. Edit project settings input. That's where you would go to. Now, last distinction, get button or get key is true or false depending on if the button is pressed. Get button down or get key down is true only in the first pressed frame. And get button up or get key up is only true on the first release frame. Okay, so get button or get key would be true for however long the button is pressed. Get button down or get key down would only be true on the first frame of the pressed key. So in order for it to register another pressed key, you would have to release and press again. Now get key up, get button up or get key up is only true on the first release frame. So you would press and release, and that would be 1. In order to activate get button up or get key up again, you would have to press again and release again. And that concludes our game production in Unity tutorial. I hope you guys enjoyed it. For those of you not in the NJIT's IT 286 Foundations of Game Production class, I hope that I still provided useful information for you that you can now apply to projects that you're working in, and to give you a more well-rounded knowledge of the conceptual and also of the technical parts of Unity. For those of you in the NJIT IT 286 class, I wish you the best of luck. on your midterm, which you would potentially be preparing for if you watch this midterm review video. And I will very soon be making a final review video, which is going to, again, be beneficial to both groups of people in that it's going to be covered the same way, where most of the material is going to be generic material, and there's going to be a few specific points that are specific to the class, you know, sort of like examples of test questions. Thanks for watching, guys, and I'll see you in the next tutorial.